Hello, uh, is my voice is audible? Good evening to all. Can someone please confirm that is the screen and visible and my voice is audible?
Yes, sir.
Okay, thank you so much. Okay, we'll start it within a second. Okay, let me just split my screen. Okay, people say join. It's okay. Okay, welcome to all of you for the week two assignment discussion of the course of control engineering. Okay. So in this week too, we'll mostly focus on what are the things that you have been discussed in the lecture. That is the Laplace transformation. Okay, how mostly because all the control system problem what we're going to deal with, we have to a major portion of the part will be discussed that implementation of the Laplace transformation. Okay, because the analysis of the things in time domain will be very difficult because of second order third order equations. Okay, so that's why if you want to solve any equation and to model the plant, okay, you need to frequency domain analysis, and for that we have to go for the Laplace transformation domain because it's a powerful tool so that you can implement it to solve higher order equations. Okay, then we'll go for the properties of the Laplace transformation. Okay, what are the various properties? Okay, mostly we'll discuss all the properties in the numericals. Okay, then how to solve the problems of the inverse Laplace transformation. Okay, and the most importantly, I'll focus on the topic that is the convolution. Okay, how you solve the equation in time domain, and also how convolution will be helpful to solve the equation using Laplace transformation. Okay, and next part will that is briefly discussed in the week two, that is what is the transfer function. Okay, and what is how to represent the system in the block diagram. Okay, so these are all the overviews of the week two. Okay, if you have not gone through the lectures, please go through it. Okay, and before solving assignments, but mostly all the things we'll cover in this numerical. Okay, with the help of numericals. So let me go to question number one. If someone want to join, one second. Okay, let us come back to the first question. Okay, the first question I am in front of the screen is that I have taken a problem on convolution. Okay, so let us consider a signal y of t which is related by x1t and x2t. Okay, so then where x1t is defined and x2t is defined, okay, the star mark represents the convolution operator. Then you have to find out the y of t. Okay, so how to find out the y of t using Laplace transformation? So how to approach this question? So first of all, you have to understand what do you mean by convolution. Okay, and what is the definition of convolution. Let's say I am taking one signal x of t, okay, and multiply with another signal, let's say y of t. Okay, so in time domain, whenever these two signals are multiplied, okay, we get some output, let's say z of t. Okay, now you have to solve this z of t, okay, from x of t and y of t. Okay, but in method in convolution, this multiplication is represented by convolution, okay, in time domain. So let me define this convolution. Okay, so this can be represented by this numerical equation x of tau, okay, and this is y of t minus tau, okay, d tau, and the integration you can take from minus infinity to infinity. This is the definition of the convolution. If two signals are convoluted, okay, if you get some output z of t, then this z of t can be represented by these equations. Okay, but if you do the solve the question in Laplace domain, then what is the formula? So one properties of the Laplace transformation, if x of t and y of t are convoluted, okay, then this is giving signal z of t, then the Laplace transformation of z of t is z of s, and this will be the signal is multiplied in the frequency domain. So this will be x of s convoluted into y of s. Okay, so now in the question your x1t is given to you e to the power minus 2t u of t. Okay, so now you know that any signal in the time domain, let's say if you represent in the frequency domain using Laplace transformation, you have to replace by s. Okay, so now if I found out the Laplace transformation of this signal x1s, okay, then what is the formula of this Laplace transformation? So e to the power minus at u of t. Let me draw this signal. Okay, this is a signal which is with respect to time. If you draw it, then with respect to t tends to infinity, is e to the power minus t, because you put t equal to here 0, it will cross somewhere 1. Okay, at t equal to 0 it will be 1, at t equal to infinity it will be 0. This is an exponential decaying signal, right? If this is an exponential decaying signal, and the Laplace transformation of this signal is 1 by s plus a. Okay, so similarly here in this x1t, your a is nothing but 2. So if you put it, what is the Laplace transformation of e to the minus 2t u of t is 1 by s plus 2. Okay, similarly if you do the Laplace transformation of x2t, what is x2t is defined by? X2t is e to the power minus 3t u of t. Okay, what is the Laplace transformation? X2s is nothing but 1 by s plus 3. Okay, so this is equation number 1, this is equation number 2. But the question asks that you have to find out y of t where x1 is time shifted, okay, by 2 unit, and x2t is time shifted in the negative direction, and then it is addition of plus 3. So first of all you have to understand what is this time shifting. Okay, then you have to find out y of s. If I find out y of s, okay, here, then you have to find out the Laplace transformation of this signal and Laplace transformation of this signal, and you have to multiply them. So first of all, if your x1t is this one, then what is the Laplace transformation of, okay, let me quickly right hand side I'll draw. Okay, then e to the power x1 t minus 2. Okay, so what is the Laplace transformation of this signal? Because you know already the Laplace transformation of x1t is x1s. Okay, then what is the Laplace transformation of x1 t minus 2? So it will be e to the power minus 2 s into x1s. This is the property. Okay, if you times this is a time delay, this 2 will be delayed signal, so it will become here e to the power minus 2s x1s. So this is the property. You have to remember all the properties of the Laplace transformation when a signal is time shifted. Okay, here is 2 is a delay in 2 unit. Okay, if it will be x1 t plus 2, then the Laplace transformation will be e to the power 2s x1s. Okay, but here we have known that x1 t minus 2 is given in the question. So for this the Laplace transformation will be e to the power minus 2s into x1s. E to the power minus 2s into x1s, you know from equation 1, is 1 by s plus 2. So this is the Laplace transformation of x1 t minus 2. Okay, let me box it. Okay, let me equation number 3. Any doubt up to this point, anyone? Please raise your hand, otherwise stop me. Okay, then the second part is very important, x2 minus t plus 3. Okay, how you solve this, how to find out the Laplace transformation of minus t plus 3, because you already know the Laplace transformation of x2s is 1 by s plus 3. Let me go to a fresh space, okay, to find out x2 minus t plus 3. Okay, so I am writing here x2 minus t plus 3. Okay, so first of all, if the signal will be given like this, there are two things are there. One is scaling, okay, other is shifting. So here, first of all, you have to find out how much scaling is there. You just take it the signal like that, x2, take a minus common, then this will be it represented by this. Okay, so now you can see, if you forget about the minus term, now for 1 second you forget about there is a minus sign. This is called a scaling factor. This is multiplied by minus 1, and this t minus 3 is called the shifting factor. Okay, forget about the scaling factor for now. You know, first of all, x2 t minus 3, what is the Laplace transformation of this one? Because this will be e to the power minus 3s into x2s. Okay, x2s, you know from the last slide, it will be e to the power minus 3s into 1 by s plus 3. x2s is 1 by s plus 3, right? But you have to again multiply this, consider again the scaling factor. First of all, without scaling factor we find out this one. Now if you consider, okay, if we consider the scaling factor, okay, the scaling factor here is minus 1. Okay, but we have to find out what is the Laplace transformation of this. Let me give an example. Let's say x of t gives the Laplace transformation of x of s. If I multiply the scaling, let's say x of a t, what is the Laplace transformation of that is 1 by mod a x of s by a. This is a formula. Okay, this is a property you have to remember. Now here a is nothing but a minus 1. Put a equal to minus 1. So if you put a equal to minus 1, the signal will be x to the power minus 1. That will be 1 by mod a is 1. Okay, x of s by minus 1 is minus s. So it means simply x of minus s. Okay, so whatever the signal is here, x2 t minus 3, this is the signal now x. Now you have to add a scaling factor, means whatever the answer you got. Okay, let me box it. Okay, this is the answer. Okay, here you have to replace s by minus s. Okay, so what is the answer you will get here? E to the power 3 of s divided by, this will be 3 minus s. Okay, this is the answer of this. This is the final answer. Now what you will do? Okay, you already got in the last slide what is okay, x1 t minus 2, and the next slide you already got x2 t minus 3. Now simply convolution is there, in time domain is multiplication in the frequency domain. You just multiply equation number 3, and I am just representing this is equation number 4. So multiply equation number 3 and 4. So final, so this is not the final answer. Okay, the final answer is equation number 3 multiplied equation number 4. Okay, I think everyone is clear. Any doubt here? I will explain it. Any doubt? No doubt. Okay,
Awesome.
So this is one of the way, but let you something solve this question in a more other way. Okay, let it. Suppose you have less time in the examinations. Okay, you forget all the formulas of Laplace transformation, but you know solidly what is convolution. Okay, then how you solve the question? Let me give an example. Okay, so before I'm coming to this question, I will just do another question for you. Let I'm giving a signal x1t. Let it something e to the power minus 3t, and here u of t. Here another signal x2t is u of t minus 2. Okay, now they are asking us to find out some y of signal y of t, which is the convolution of x1t and x2t. So there are two options for you. If you are expert in Laplace transformation, you find out the Laplace transformation of this signal. I am just quickly drawing here x1t. Oh, so y of a is equal to x1s multiplication x2s. Okay, so I'm directly writing here x1 is Laplace transformation is 1 by s plus 3, and x2t Laplace transformation is e to the power minus 2t. Simple. Okay, so now what you do, you have now finding out y of t is take the inverse Laplace transformation of y of s. Okay, you find out the answer, you will get the y of t signal. This is one way. What is the other way?
Sir, doubt, sir.
Sorry.
Sir, after e to the power of minus 2t, shouldn't there be 1 by s, sir?
Yeah, because e to minus 2t and u of t Laplace transformation is 1 by s. Right, you're right. Okay,
Sir, thank you, sir. Thank you, sir.
so this is y of s. This is take the inverse transformation of this y of s to get y of t. But if you don't fail, again you have to take the inverse Laplace transformation. Okay, but suppose in the examination you don't have time, then how we approach this question? Okay, let's see. Let me directly go to the definition of convolution. So what is the convolution definition? I told you the convolution definition is, if there are two signal x1t and x2t, if you other signal you have to find out the convolution of x1t and x2t. So what is the formula? x1 tau. Okay, just I am changing the time domain to another some scale to tau. Okay, let me call it like x1 tau, then x2 t minus tau. Okay, d tau you have to integrate with respect to the other variable from minus infinity to infinity. Okay, now how to solve this question? So let me solve here. So you have just graphically solve the question. That's it. My aim is to how to you graphically solve this question. So first of all, what you do, whatever the signal is there, you have to draw it. Okay, let me draw the first signal, e to the power minus 3 tau. Okay, at t equal to 0, the signal will be 1. Okay, it will be something like that. Okay, so at t equal to 0, it will be something like that. But because u of t is there, that's why the signal, I am not taking the negative part, because u of t is multiplied means your signal will be only restricted from 0 to infinity. Okay, and t equal to 0, the signal will be 1. So this is the first signal you draw it. But what I did, just to go to my formula, what I did, now I change the scale to tau. Okay, so now here whatever the time domain is now changed to another scale. Let's see tau. Okay, this is a tau signal. I am just writing is x1 tau. Okay, next to another signal, u of t minus t. U of t minus t, draw that signal first. This is u of t minus 2. So I'm having a delay of 2. Okay, so it is starting from 2 and it is going up to infinity, having an amplitude of 1. And this is, I am saying that this is x2 tau, because I changed the scale only. Okay, so now this reference scale is now not with respect to time, with respect to other time tau. Okay, another reference frame, you just think like that. Okay, now, but what you do, x1 you got, x2 t you got, but you have to x2, you have to find out x2 t minus tau. Okay, if you're very smart, then what you do, you have to first forget about this addition 2. You first find out x2 minus tau, how much x2 minus tau is there. Okay, x2 minus tau is how much? Minus tau means you have to just take the mirror image of the signal. Okay, so now I am drawing x2 minus tau. What is x2 minus tau? This signal take the mirror image. The mirror image something with respect to y-axis. Okay, so it will be minus 2, and it will be up to infinity, having an amplitude of 1. But in this signal, you have to add an extra variable, okay, a constant term, because this is a variable with respect to tau, but this t is a constant you are adding, okay, in everywhere in the x2t. Now you add a signal in every place, you have to add, okay. So here the signal is from minus infinity and here up to infinity. At every point, if you add t, let me add t here, t here, t here, everything. At minus 2, you have to also add a variable 2. So now this point is not minus 2, this point is minus 2 plus t. Okay, once you do it, okay, in graphically in one line, then what you do, convolution is nothing but the common region between these two signal. What is the signal is now? X1t and x2t minus 2 is multiplied. So now you take a multiplication. So what I do, this signal on the right hand side, I am now superimposing on the left hand side x1 tau. Okay, so what I did, I am just drawing the signal here. Here this is x2t minus tau. This point is minus 2 plus t. Okay, now here amplitude is 1. This signal on the left hand side is x2 t minus tau. Okay, now what you do, your aim is to now multiply these two signals. If you multiply, means multiplication will only happen when there is a common region. Okay, now you can see here, whatever now you are seen on my screen, there is no common region between the two signals. It means whenever the first case is coming, minus 2 plus t less than 0. Okay, it means whenever your t should be how much, this value t should be less than equal to 2, it means there is no common region, the answer will be 0. For this part, the answer will be 0, y of t equal to 0. Okay, now suppose this t constant term, you don't know what is that value. It can be anything between minus infinity to infinity. Let me add this value t to a larger value. I am adding this t, let's say t equal to 5. If t equal to 5, you can add minus 2 plus 5 is 3. It means this point is now shifted to another point. This point is now shifted to 3. Now your minus 2 plus t is here. Okay, if which case you are considering, your minus 2 plus t should be now greater than 0. In this condition, this point is coming here. Now what will happen, there is a common region you are finding out between the two signals. Okay, if the common region is finding out, then what do, you just find out the amplitude of both the signals and the equations. So from, I'm just writing here, from in this range, when minus 2 plus t greater than equal to 0, then what you do, you first find out what is x1 tau. X1 tau is nothing but e to the power minus a tau. Okay, e to the power minus a tau. Next, what is x2 t minus tau? X2 t minus tau having an amplitude of 1. So this will be amplitude 1. Now you have to multiply these two signal from which value to which value? From 0 to minus 2 plus t. From 0 to minus 2 plus t is the limit. Okay. Now you integrate this signal and find out the answer. Okay. Whatever the answer, that is your answer. Okay, so if you are very strong in doing all these things, then you don't need to go for the Laplace transformation and inverse Laplace transformation. This is another way, that from the definition and from the graph you can solve the question. Okay, otherwise there are lots of properties also, convolution also there, you can solve that way. Okay, so that is my not aim. My aim is to solve this equation using Laplace transformation. I have to familiarize with you the Laplace transformation, but there is other way also you can solve from the definition of the question. Okay, so that you can do by yourself. Okay, so that's the homework. You can, if you have seen any question on convolution, first try to attempt with respect to graphically. Okay, then you go for the Laplace transformation and inverse Laplace transformation. Okay, so now come to the second question. Okay, so question number 2. So find out the inverse Laplace transformation of this question. Okay, so let me give, this is one x of s. Okay, now just find out, can tell anyone tell me the answer? How many of you are aware about the inverse Laplace transformation? Okay, let me do for you. Forget about something multiplied, e to the power minus 2s divided by s plus 3 whole square plus 9. This is the question is given to you.
Sir, I have a doubt, sir.
Yeah.
Sir, you have said now, sir, in previous question about convolution, sir.
Okay, okay, yeah.
Yeah.
Come in. Okay, yeah.
Sir, I have a doubt on convolution, sir.
Right.
Sir, sir, input if input signal is u of t and system is h of t, no, sir. We do convolution, no, sir.
Yes.
Then in real life, does it really happen, sir? Like if you send input signal to amplifier, it amplitude will be multiplied, no, sir.
Right.
Increase, no, sir.
Right.
Like that, this convolution property happen in real life, sir. If system is applied with an input signal.
Yeah, actually, I am just saying that here I am considering two systems. Okay, one system x1t, you have a impulse response having a h of t, it giving an output y of t, right? And the second signal is x2t having a impulse response x2t and multiplied with h of t, you are amplifying it, and you got some y2t. Now, I am just asking you that you have two systems now. The two system is multiplied. Okay, you have two system is interconnected by some means. Now in that case, how to find out your output is none other, always not the case that you have only one in, because you have multi input multi output system in control system. Okay, so let's two inputs are there. Now these two inputs are some combined in some way. Here the some way is like that, the e to minus 3t u of t and multiplied with u of t minus 2. Now how you find out the output of this multi input system? So that I'm showing you that these convolution properties help you to find out. Okay, this practical lots of examples are there if you go for multi input systems. Okay, the two multi input systems are combined, how they are combined to get the output. It's like that. Are you getting my point?
Yes, sir. Ah, yes, sir. Thank you, sir. Thank you for explaining, sir.
Okay. So now, okay. Now you solve this question. Let me add someone is waiting for it in the waiting room. Just solve that question in my screen. Hello. Yes. Yeah, it is going on. Count is still 10, sir. Okay, okay. Actually, the session is going on. People are. I'm in the class only. Thank you. Okay. Actually, I had attended the call. Sorry. Okay. So let's go to the question here. What is the inverse Laplace transformation of this signal? Try to solve this question. Okay, let me solve for you. Okay. Let's say this is s plus 3 is given to you.
Hello, sir.
Yeah,
Yes, I tried to join the meeting on desktop, but I could not join.
I think you're
But now
already.
I have joined through the mobile phone and I joined.
Okay, so it is a problem. You just find it out. Okay, I'll talk it later. Okay, and the class is going on.
Okay, okay. Thank you.
Okay, so the question is s plus 3 divided by s square plus 2s plus 1. Okay, please unmute yourself. So now I am just finding out the inverse Laplace transform of this one. Okay. So now what you do, you have to simplify this equation. Okay, this s square plus 2s plus 1 is nothing but your s plus 1 square, right? So now after solving this one, what you do, You have to simplify it. Either you can use partial fraction, okay. In the partial fraction you can solve it by dividing a divided by s plus 1 if you are very familiar with partial fraction, okay, s plus 1 square. But I always try to simplify in let me see that how I am simplifying it. If you do partial fraction you also find out a and b, okay. This is one way. The second way is that this question look like simple for me. So what I do, I am just whatever in the denominator I just want to replicate it. Let me s plus 1 is the denominator is there, you just replicate that in the numerator. Let's see s plus 1 plus 2, I am just replicating it. This will be s plus 1 square. Now what you do is segregate it. Let me keep it s plus 1 like that and s plus 1 square like that, and here 2 divided by s plus 1 square, okay. So now if you simplify it you will get 1 by s plus 1, okay, and this will be your 2 divided by s plus 1 square, okay. So now here after finding out this let me call it g of s is given in the question, okay. This is your g of s. Now what is g of t? The inverse Laplace transformation, that is you have to take the inverse Laplace transformation of individual term, okay. So let me do for the first term. What is for the first term? What is the answer? 1 by s plus 1 square.
So it's 1 by s plus 1 only, sir, the first case.
Okay, 1 s plus 1 is cancelled, right? You're right. Thank you. Thank you for pointing out that. So it will be how much? E to the power minus t
E to the power minus t.
u of t. You have to always multiply u of t, okay? Next, for the second term, 2 times of e to the power minus t u of t is will be fine, but there is a square term is there, okay. So whenever t is multiplied to any signal except t, to find out the Laplace transformation, then it will be 1 by s square, okay, into x of s. So like that, here a square term is there means one t should be multiplied here, so answer should be you have to multiply t here. So this is the answer for this question. G of t equal to this is the inverse Laplace transformation, okay. So now from this discussion I just want to point out few things, okay. These are very important for you for signal construction, okay. Let me give a quick example to you, because I just remembered that, okay, how this t, what is the meaning of this t? Whenever t is multiplied to any signal, what is the meaning of that? Okay, let me before coming to this question, we'll solve this question later, but keep a space here. Now tell me, suppose you want to construct a signal. Let's say I am giving a signal like that, okay. Here this is a time domain, this is something infinity, okay. Now here this amplitude is also, it is also infinity. Let's call this signal is x of t, okay. So what is the equation of this signal? Can anyone tell me quickly?
X equal to T, sir.
X equal to t. Don't say t from now, because this is a right hand side signal. Always say t u of t, right? You have to multiply always u of t signal, because it is a right handed signal. So this t u of t is nothing your r of t, okay. This r of t is called your ramp signal, okay. This is the first what I'm saying. The second question I'm developing for yourself, okay. Now tell me, if you know the equation of this line is t u of t is nothing but r of t. T u of t is nothing but r of t. Now, so now what is the equation of this line? What is the equation of this triangle now? Let me call this amplitude is 1. Now for simplicity take it 2, and this is 0, and this point is 1, this point is 2, and this is the infinity signal. This is, let's say, x of t. Again, quickly tell me what is the answer, what is the equation of this triangle? If you solve these two questions, then I think the question that I showed in the left hand side, we can reconstruct it, the equation will find out, and then after finding out the equation, we'll able to find out the Laplace transformation, okay. So now tell me how to find out the equation. Can anybody tell me quickly? Okay. So first of all, before solving this question, you said me that, sir, this is an infinity signal which is going up to infinity here, up to infinity, and here is t u of t. Now how to solve this question? Now you see here, always whenever you see a ramp signal, your aim is to find out the slope of the line. Now first of all, for the first segment, this is segment 1, I'm just calling segment 1, this is segment 2. For the segment 1, tell me the slope. What is the slope of the line of segment 1?
2, sir.
Okay, height is 2 and this distance is 1. Okay, y by x, slope is nothing but dy by dx. Okay, change in y is from 0 to 2, so height is 2, and the change in x from here to here, segment 1 is 1, so dy by dx, you find out the slope, that should be 2. Okay, but this is the slope, and this equation is starting from 0 and it is going from 0 to infinity. But at one point, let's say you are sitting at one point. Suppose you are not sitting at one point, then forget about the segment 2. If previously segment 1 will be there, then what the signal will be go up to infinity in that way. Okay, but at one point there is another person is sitting. What he is doing, he is pulling his leg. Okay, let me, he is pulling his leg and is down, making the signal to down and come to 0. Okay, so what you do, if you solve this type of question, see, if you follow this way, you can write in one line what is the equation of this. So first of all, for the segment 1, you know that the slope m equal to 2. Okay, so just write the equation of the line. The equation of the line is nothing but the slope, okay, into r of t, because r of t, you know that this is t u of t, which is from 0 to infinity. The signal is going up to infinity. Previously the signal was going from 0 to infinity only. Okay, if at this t equal to 1, that person is not sitting and pulling him to the backward, then the signal always grow from 0 to infinity in that slope m equal to 2. So for the first segment, the equation of the line is nothing but 2 into r of t. 2 is the slope of the line, r of t is nothing but t into u of t. Okay, now what is happening here? You see at what slope it is going. I am assuming that this angle is 45. You take any angle theta. I am not say 45. Let's say this angle is theta. So it means from this horizontal axis, okay, because if you draw a parallel line, this angle is also theta. Okay, so means this, by making an angle theta, the signal is going from 0 to infinity with a slope m equal to 2. So that's why I'm writing the equation of the line is 2 into r of t. But if at t equal to 2, in what slope it is moving? It is moving in the slope of theta. The same slope, someone is pulling him down first. Let this person at t equal to 1 pulling him down. If he is pulling him down, then what happen? The signal will be go now in vertical, this line, parallel horizontal line x-axis. But he is not stopping at that point. He is again pulling with the same slope theta again to this direction. Now the signal which is now moving from this line to here, now he changing its direction from here to here. So how many theta he is moving here? 1 theta and there is 2 theta. Okay, so in what slope you are rising, double of that slope you are falling. Okay, so first of all write that equation here. So here you have written for the first segment, this is the equation of the line 2 r of t. I'm just writing it completely here, 2 into r of t. Okay, now at t equal to 1, the same slope it is falling back, so I'm writing the same slope 2, and which point? This is r of t minus 1 point. You are falling and you are now moving in the horizontal axis, this axis you are moving. But still again you are again at the same slope theta, you are falling and you are falling and you are moving in this direction. Okay, now so I am drawing another with the same slope, is 2. Okay, r of t minus at which point now? This is again at t equal to 1 point. Okay, now at one point that person is pulling you in this direction, okay, but there is another person is sitting at t equal to 2. What he is doing, he is adding the positive slope. He is not making you down, he is making you up. Okay, with the same slope theta, and now we are moving in the x-axis. Okay, so what happened? The same slope is 2, and here you are that person is adding you and that is the, what is that value at t equal to 2. So now you can see this is the equation of the line. How many of you cleared this equation of the line, how I draw it? You're not clear, then tell me, I will explain you again.
Sir, please repeat again, sir.
Okay, let me go to fresh page. Okay, let me start with some quick question like that. You know what is the equation of this line? You first tell me what is the equation of this line. This is 1, this is 1. Tell me what is the equation of the line. What is the equation of this? This is 0. So u of t, right? So what is happening? If I write u of t means at t equal to 0, your amplitude is 1 up to infinity, right? At 1 up to infinity. Okay, but you see that there is another person which is sitting at t equal to 1. He is not allowing you to go in this direction. What he is doing, in place of that, he is pulling your leg to down and go in this direction. It means whatever the height you are here, 1, here the height means, remember, whenever this type of square signal and rectangle signals are there, always don't take your slope, always take the height. But whenever ramp signals are there, always you take the slope. Okay, so now here the height is 1 and u of t, this is 1 u of t, so 1 is 1 only, that's why I'm writing u of t. So u of t means it is a signal like that up to infinity. Okay, but there is another person at t equal to 1, he is making a leg down and he is pulling your leg and he is just doing like that, so that you can have a signal like that. Then what is happening at t equal to 1, there is an amplitude of -1 shifting, so you write down -1, but again the same u of t is falling down, but this is at t equal to 1, that's why u of t -1. So now if we write down the equation of the line, equation of the signal, this is u of t minus u of t minus 1. This is a very basic question, I think you understand it, how I am writing the equation of this pulse. Okay, you understand it?
Yes, sir. Yes, sir.
Okay, if you understand this, I am just using the same logic there. What is the same logic? Let me give an example to you. Now let's say this is a sawtooth wave. Okay, I'm just doing only one cycle of sawtooth wave. Let me 0 and this is 2 and this is 2. Now you just write down the equation of this line. How to do that? You first see that the equation is starting with a slope. Okay, and what is the slope of the line? The slope of the line is height is 2 and this x distance also 2. The slope is 1. But okay, once you know the slope is 1, this is a r of t signal, right? R of t is nothing but t u of t. So this, let me call this r of t. This is a ramp signal, that's why I'm denoting is r of t. But remember, r of t is nothing but t u of t. Okay, so here the slope is 1, that's why we are writing here 1. Now if I write, sorry, just someone has to mute it, please. Okay, if it is r of t signal, then r of t signal, you know that this signal is up to infinity, but the signal is coming down. How it will be come down? See, if you are going up to, in this projectile motion at some angle you are making and going up to infinity, if you want to come down here, first of all, someone, whatever the slope here theta, with the same slope you have to come back first. With the same slope you come back down, then now the signal will be here in this direction. You understand my point? There is one person
Yes,
is
sir.
sitting at t equal to, let's say, 2, and he's pulling you, and now in place of moving upward, you are now moving in the right hand side direction. So in that case, how you write the equation? R of t, same slope I am saying, because here the whatever the slope you are rising, the same slope you are falling down. So that's why the same slope is 1, but is a negative slope, that's why it's r of, and at which point, this is at t equal to 2 point, that's why r of t minus 2. Now you understand that at which point you are lying, you are now the signal, whatever the signal I have written here, now at this is the position, you are moving on the right hand side horizontally up to infinity. But the question that I have given you, like that, you have to stop at this point. Okay, so what that other person is doing, he has to add a step signal here, whatever the things we have done here on the first question, the same height, whatever the height you are going up, the same height is 2. Now at 2 same height, what is the unit step function you have to add here? U of t minus 2. If you do that, then instead of going to the horizontal, you can come and settle in the x-axis. Now this is the equation of the line. You understand?
Yes, sir.
So if you understand, then can you understand this one by yourself?
So,
Okay. So let me quickly draw you for you. Okay. These are the examples. Okay. So now
Sir, please explain this last one, sir, again, please, sir.
last point means okay.
From R of t minus R of t, that
Okay.
one
Okay.
explain.
You first understand that the first segment, this is segment 1 I'm calling. The segment 1 equation is R of t with a slope having 1. Let me change the slope for you because always you're thinking 1 is 1. I'm giving always 1. Let me give the equation, this is 4 and let's say this is around 8. Now you can say what is the slope? dy change is y 8 and x infinity is 2. Now the equation of the slope is 2. 2 R of t, right? This is the first segment 1 I am drawing. Segment 1 slope is 2 and having a R of t signal. Now you are moving in the air, okay? In the air you are moving with the angle making whatever the angle from the horizon theta, the same angle from this horizontal axis you are moving correctly. Now what is happening? But your direction is not that way. What is your direction? Your direction has to come and you have to settle at this point, okay, and you have to mix with the ground. Then you are originally moving in this direction, but first of all, with what slope you are rising, the same slope you have to fall down. If you rise at theta, and if you same slope you fall down, then what will happen? You have to again come to the horizontal line, okay, because from the horizontal line you are moving at theta. If from that theta, if you again come back, you will be having a horizontal line. So I'm writing the same slope is 2, okay, but at which point you are falling it down? At t equal to 4. So that's why I'm writing r of t minus 4. But now you are moving in this direction, okay, you are moving in the horizontal axis, but your origin is that you have to come to the horizontal x-axis, not with a shifting of 8. So whatever the shifting is here is from 0 to 8, so that unit is a unit step function. It is not a ramp function now, because only that height has to be come down. So that's why 8 units you have to come down, but at which point you have to come down? At t equal to 4. That's why u of t minus 4. You understand this point?
Yes, sir, yes, sir. Thank you, sir.
Okay. If you understand, then please quickly solve this. Okay, just whatever the equation I gave it to you, the first one. This is a very critical equation because people uh, they ignore it, but it's very simple actually. Don't fear it. Okay, let's say 0. This is 2. This is 4, and this is again I'm just taking 2. This will be 4. Okay, just quickly I'm writing down. Okay, if I do any mistake, then tell me. For the first segment, I'm writing what is the slope of the line? Height is 4, this distance is 2, that's why slope is 2, and I'm writing r of t. If you don't understand any particular part, you tell me. Then at 4 you have to come down, but at which slope you are moving? You are moving at the slope of theta. If you come down, but you have to come down to this line, okay, you have to come down to this line, to this line, the slope will be 2 theta, because there is a horizontal line is there. This is theta, another theta, so 2 theta you have to fall. That's why I am writing directly 2 theta means 2 slope. What is the slope? 2. So I am writing directly 4, at which point you have to fall down r of t minus 2. Now if you fall down at 2 theta, now you are moving in this direction, but after that you have to go to the x-axis. That's why you have someone has to add you in the positive slope, the same slope, okay, the same slope is plus. What is the slope? 2. So r of t minus 4. This is the final answer. Everyone clear? Is it okay?
Yes, sir.
Okay, if it is okay for you, then solve that question number 3 what I've given to you. Tell me the answer. I will not explain it. So first of all, This is a unit step signal with the height is 2 is given. So write down that height 2 into u of t, because it is starting from 0, but now you are moving in this direction. Okay, you are moving in this direction up to infinity. U of t means what? It is 0 to infinity. But you are not moving in this direction. You have to come down. Here, how much time you have to come down? You have to come with a height of these 2 and the negative 2. So you have to come with a height of 4 first down. So write down minus 4 u of t minus t, because at t equal to t you have to come down. So up now you are now moving here in this direction. Understand? Because previously you are moving in this direction. This direction is 1. If you fall down by same height, now you are moving in this direction too. But it is not the final destination you want to reach. At the final destination, you have to making an angle theta. You move with a ramp slope. Okay. Now if you move with a ramp slope, find out the slope of this line. What is the slope of this line? The height is 2. The height is 2, and the time also from 3t minus t. Change in x is 2t. So write down that slope here. So here I'm adding. Here you have to add, na, because this is you have to increasing slope. Okay, you have to add something, that's plus. Okay, so this will be 2 divided by 2t. Change in y is 2, change in x is 2t. But here is a ramp signal. At which point? At t equal to t point. So t minus t. Now you are moving in this direction up to infinity. Understand my point? But it is not a destination. The destination, you have to come back and reach on the x-axis with a falling slope of same slope. At which slope you are rising? What is the slope you are rising? 2 by 2t. The same slope you have to fall down. Minus 2 by tt. Which point? R of t minus 3t. You understand? If you don't understand, then tell me, I will explain it one more time. But you have to be clear this approach. So the final expression I'm writing here, 2 u of t, we are falling with a height of 4, u of t minus t, then we are rising with a slope of 2 by 2 cancel, so this will be 1 by t, r of t minus t. With the same slope we are falling again, so 1 by t, r of t minus 3t. This is the equation of the graph which I have given to you. Now for this equation he is asking us to find out the Laplace transformation. So find out the Laplace transformation. 2 divided by s minus 4 into e to the power minus st divided by s plus 1 by t, r of t is nothing but t into u of t, so 1 by s square will become the Laplace domain, and this will be e to the power minus st minus 1 by t into 1 by s square into e to the power minus 3st. Is this okay for you? If not okay, then tell me, I will explain it one more time, but you should have to be clear all this approach. Everyone, please respond.
Sir,
Yeah,
sir,
yes, yes.
can you explain the third part, that it's 1 upon t r of t minus t?
Okay. Let me go to a phrase space. Okay. Here I'm drawing it again. Try to understand. Actually, you have to practice 2-3 times so that you can be expert in this. Otherwise, if you don't practice, it will be trouble. This is the I'm just changing my color for you now. This is the equation of the line which I have given to you. This is 2, this was 2, I think t, and this is 3t was given, and this one is also minus 2. This was given to you in the question. So for the first part, what I did, The first part, it means this is a rising 0 to t. So I am writing 2, and this is a unit step signal which is from 2 to infinity. Okay, so u of t, 2 u of t, it means it is a signal like that. It is having up 2 and it is going up to infinity, but it is not your direction. Your direction at t equal to t, you have to come down. If you have to come down, by how much distance you have to come down? You have to come down by a distance of 4. So write down at which point you have to come down. You have to come down at t equal to t. So I'm just erasing here, minus 4 u of t minus t. Now whenever you come down, you just see previously you are moving in this direction. If you fall on the same height, then you have to move in this direction. Okay, so now this path is now, this path 1 is now becomes path 2, but you don't want to go in path 2, you want to go in path 3. Okay, but from path 2 to path 3, how you go? You have to go by changing the slope. This slope is theta. This theta means this is also theta. This theta is nothing but change in y divided by change in x. Change in y is how much? Change in y is 2, and change in x is 3t minus t. That's why I am writing the slope here. How much the slope? This will be 2 divided by 2t. But here the slope you have to make from path 2 to path 3, you have to take a positive slope. That's why here the plus sign will come, 2 by 2t. And now you are moving in a ramp signal, r of t minus, at which point you are moving, at which point you are making it upward, at t equal to t, same t. Okay, that's why r of t minus t. Now you are moving in this path 3. Okay, path 3 is from infinity, because r of t is a signal which is from infinity. But you don't want to go in path 3, you want to go in path 4. The path 4 is this horizontal line, so you have to follow the same slope theta. So from path 3 to path 4, the same slope 2 by 2t, you have to fall down. And at which point you have to fall down? At 3t point. You understand now?
Yes, sir. Yes, sir.
Clear? Okay. So if it is clear now, we'll that type of question will stop here. Now you come to the next part. Okay, so now this is another way of the application of the Laplace domain to find out the initial value theorem and what is the final value of any expression. Let me give you the question. You read it properly. Find the initial value theorem. Just read it and tell me the answer quickly. Just 1 second. Yeah. So this is the initial value theorem question. Okay, how to solve that? So initial value theorem means find the initial value f of 0. So what you do, you put f of 0 here, delta of 0 plus 3 into e to the power minus 0. So what is the delta of 0? Anybody can tell me?
Infinity.
It should be infinity. Infinity plus 3 is infinity. Okay, so the function at f of t, the value is infinity. Okay, it means this is not a stable signal. This is not a stable signal. Also at t equal to 0, the amplitude is infinity. It means it is an unbounded signal. Okay, so by this way you can say that the initial value theorem cannot be applicable, because the initial value theorem is only applicable when the signal will be again a bounded signal. Okay, so how can you prove this? Okay, suppose somebody don't know what is the value of delta 0 at infinity. Okay, most of the people think that delta of 0 at equal to 1. Okay, this is wrong. Delta of 0 is equal to infinity. Okay, so now what you do, you have to, there is a finding out the initial value theorem. Let's say f of t at t equal to 0 is nothing but you have to find out the limit s tends to infinity s into f of s in Laplace domain. Okay, so what you do, first of all you find out the Laplace transformation of this signal f of t. So f of s is nothing but Laplace transformation of del of t is 1, okay, and 3 e to the power minus t Laplace transformation is s plus 1. So this is your f of s, okay. Now you put this in equation. In this equation, if you put it, you will get the initial value theorem. So limit s tends to infinity, s into f of s, so 1 plus 3 divided by s plus 1, okay. To multiply it, okay, you will get limit s tends to infinity, s plus 3s divided by s plus 1. If you now put it s in place of s, you put infinity, then something will be infinity plus something. Infinity plus something is again infinity. It means signal is at t equal to 0. It values infinity. It means the initial value theorem is not applicable. Okay, the initial value theorem is not exist. Okay, so this way you can solve the initial value theorem. Let me, someone is trying to join. I don't know why people are joining this time. Okay. So this is the initial value theorem. Let me go to another question of quickly same type. What is the final value theorem? Okay, I am just writing the final value theorem formula. Final value theorem means we have to find out final value f of t final value. Final value means at t equal to infinity. Okay, so in Laplace domain is nothing but limit s tends to 0 s into f of s. Okay, so f of t is given to you 3 into e to the power t. So what is f of s? 3 divided by s minus 1. Now I put in this equation and find out limit s tends to 0 s into 3 divided by s minus 1. If you put s tends to 0, okay, so what is the value we'll get here? Limit s tends to 0, 3 into 0 divided by s equal to 0, 0 minus 1. Okay, so this will be 0. So what is the answer? What is the answer of this question?
-3.
Minus 3. How will you get minus 3? 3 into 0 is 0. 0 by something is 0, right? So the answer should be 0, right? Yes or no?
Yes, sir, it's 0, sir.
Okay. So actually
Yes,
what is
sir. 0,
happening?
sir.
This question actually is given. Suppose you will put 0. You are thinking that you will get a 2 marks. Okay. But you will get a negative minus 2. Because the answer is not 0 for this question. Okay. It looks like it is 0. And in the option it is 0 is there. But for this question, you have to remember that this final value theorem is only applicable for a stable system. Remember, a system should be stable. It means all the poles and zeros of all the poles, not at 0. I'm just taking my line back. So final value theorem is only applicable for a stable system. Stable system means when all the poles are lies in the left hand side of the S plane. Now immediately what you check here, first of all, whatever the function is given, if you are very smart, then what you do, you in the time domain you try to draw that signal 3 into e to the power t. At t equal to 0, this amplitude is 3, and at t equal to 1 it will be increasing. At t equal to infinity, this is infinity, so this is an exponential rising signal. Okay, now can you look and tell me at t equal to infinity, final value means at f of infinity, at f of infinity, is the value is converging? Is the value is converging at 3 or somewhere? The initial value is 3 and the final value it cannot be 0. You can see here it is increasing and it going, and exceeding the sky and it is merging in the universe and it, okay. So at t equal to infinity, the value is infinity because it is an unbounded signal, it is an unstable signal. In time domain also you can verify that this, if the signal is unbound and unstable, final value theorem cannot be applicable. Then also in Laplace domain you can see that f of a is equal to 3 divided by s minus 1. If you find out s minus 1 equal to 0, you can see that s equal to 1. Clearly that the pole is on the right hand side of the s plane at 1. So this system is unstable. So final value theorem is not applicable. Okay, so these 2 points, remember that, go and read first whenever initial value theorem is applicable and whenever final value theorem is applicable. After that, you have to check the condition. Before that, you don't check the condition. If it is applicable, then I will check. If it is not applicable, then I should not check it. So the answer for this question is final value theorem is not applicable. Okay, this is the correct answer. Is it okay for everyone? Okay, if it is okay, then let's move to the second question. Next question, question number 6. Okay, so this is a powerful equation. Okay, this is a powerful circuit. Most of the times in GATE exam, I saw this type of questions. They only change R1 C1 values and they will ask you to find out the transfer function of the system, because in a control system, if you find out the transfer function, then only you will able to do the solve the question, the rest of the part of the control system. It's like you have to find out the root locus, you have to draw the Bode plot, you have to find out the stability of the system, you have to find out the Nyquist plot. Okay, all these things will come once you will be very strong to find out the transfer function. And how to find out the transfer function? You are very good at mathematics and you are very good at Laplace transformation. So these two are the basic of finding out the transfer function. So for this is an example of the question. This you can see that this is an that electrical engineer, you should be know that if a RC combination is given to you, this is R and this is C. This is a low pass filter. Okay, if any signal I am giving here x of t, then it will only pass the low frequency component and it will attenuate the high frequency component. Here what is happening? One RC network and another RC network are cascaded together. It means it is a second order low pass filter. Okay, the second order low pass filter. So for this second order low pass filter, now the question asks you why I have taken that question, because now from now onwards whatever the answer will come V out by Vn, you have to memorize it, or otherwise you have to write it somewhere before you going to attend any competitive exam, because this more directly this question will come with the R and C value different. You have to just plug and play and find out the rest of the part. Okay, so let me allow someone. I just okay. So for finding out the Laplace finding out the transfer function of this equation, so first step what you have to do, you have to write the KCL or KVL equation of this. Okay, so what you need to do, you just yeah, let me change color. So okay, you just need to write out the KVL equation. So write out the first KVL equation and the second KVL equation. There are two loops are there. So the first loop, the current is flowing here. Let's assume that y1. Here this current is I2. Okay, and here the output V out is given. So for the first loop, I am applying a KVL on the first loop. So can anybody tell me what is the equation? I am writing minus Vn plus I1 into R1. Okay, we have to move in this loop. Okay, here the current direction is downward. So always in a capacitor or resistor inductor, the current is always flow from positive to negative terminal. Okay, so now you write down 1 by C1 integration of what is the net current here. I1 current is flowing here, I2 current is flowing out. So I1 minus I2 into dt equal to 0. This is equation 1. What is the Laplace transformation of this one? Minus V in by S plus I1S R1 plus 1 by C1 into S. This is I1 minus I2. So I'm writing directly I1S minus I2S equal to 0. Okay, let me call equation number 2. Everyone is clear about the first equation KVL 1? Yes or no?
Sir, why?
Yeah, yes, tell me.
Sir, why did we get in VN below denominator?
I'm sorry, your voice is not clear. I don't think it's clear to all.
Sir, in below VN denominator there is S, no, sir.
Yeah, here.
No, sir. Below VN, sir. V input.
Okay, so you should not write Vn by
Sir.
S because that is a
I,
constant
do-
term, na?
I,
What is the Laplace
yes, sir.
transformation of a constant? U of t, right? Just U of t is 1 by S, right? So minus being just a constant of a positive signal. So you have to write 1 by S, right?
Yes, sir. Now I understood, sir. Thank you,
Okay.
sir.
So after writing this equation, then similarly write down KVL2 for the second loop. For the second loop, you move in this loop and write down the equation. The current will be flowing from here positive to negative, because in any passive element the current always flow from positive to negative, and the current direction is this way. That's why I'm taking directly here I2 R2. Here in the capacitor the current is again moving downward. So what is that value? 1 by C2 and integration of I2 into dt. Okay, now in this capacitor C1 the current I2 is moving here upward and I1 is moving downward. So the net current, this is this plus minus for the first loop. For the second loop, this is now I'm changing the color, and you can see the current is moving from plus to minus here in this. Okay, I2. So now you can write down this will be plus again 1 by C1, but here now the net current is I2 minus I1. Sorry, I2 minus I1 into dt equal to 0. Equation number 3. Now you find out the Laplace transformation of this equation. I'm just writing here. The Laplace transformation of this equation is I2 into R2, so I2s into R2, okay, plus 1 by C2 into I2 dt. So 1 by C2 into S I2 S plus this one 1 by C1S, this should be I2 minus I1. This will be I2S minus I1S. Okay, is equal to 0. This is equation number 4. Just I'm doing the Laplace transformation carefully. Okay, Now here another equation I can write, the output voltage equation. V out is nothing but the current in the voltage across the capacitor. Okay, so what is the voltage across the capacitor is 1 by C into IDT. Okay, so write down another equation. V naught is nothing but 1 by C2 into I2 into dt. This is equation 5. If you Laplace transformation of this one, this is V naught S equal to 1 by C2S into I2S. This is equation number 6. So all the Laplace transformation equation like 2, 4 and 6, okay, solve it by yourself. Solve equation number 2, 4 and 6, okay, and you have to express V naught S in terms of V in S. So now I am writing the final equation. Now that final equation you have to memorize or you have to keep it in note somewhere. So this V naught S divided by V in S is nothing but 1 divided by the second order equation, right? So R1 R2 C1 C2 into S square plus R1 C1 plus R1 C2 plus R2 C1 R2 C2 into S plus 1. So this is the final expression. You solve it, you can find it. Okay, it's very important from any competitive exam point of view. Now in the previous slide actually I have given the values of everyone. R1 R2 C1 C2 is 1. Okay, if you put in this equation R1 equal to R2 equal to 1 and C1 equal to C2 equal to 1 farad. Okay, now whatever you write V naught is y V in S is nothing but everything is 1, so S square plus here is 1 1 1, so it will be 3 3s plus 1. So this is your transfer function. Now what is the question he is asking to you in the previous slide? He is asking that if all the values are 1, then tell me the electrical system has distinct and negative real roots, repeated and negative real roots, distinct and positive real roots, or repeated and positive real roots. So to before finding out reading the, you just find out the roots of this equation, because this is the transfer function. If you find out the root of this equation, then what you need to do, you just find out, okay, S square plus 3s plus 1 equal to 0, the second order equation. So what is the root? Roots are minus b means minus 3 plus minus b square minus 4ac. B square is 9 minus 4 into 1 into 1. So b square minus 4 is square root divided by 2a, 2 into 1. So the roots are minus 3 plus root 5 by 2. Another is minus 3 minus root 5 by 2. Okay, this is the positive number, whatever, this is a negative number. So both are distinct. Okay, so both are distinct values. There are two different points and they are real. Okay, because there is no imaginary term is there, so they are real and distinct. So and both are negative. Okay, you can see which option is correct. Distinct and negative real, and option A is correct because both are distinct and both are negative. It is clear to all of you? Okay. If it is clear, then move to the next question. So this is also a very powerful question. Actually, most of the time in examinations, they will give a transfer function to you and they will ask you find the DC gain of the system. What is the DC gain of the system?
It's point 0.4, sir.
Sorry,
Point 0.4.
we are saying 2 by 5 is 0.4, right?
Yes, sir.
Okay. Okay. The answer should be DC gain means you have to put S equal to 0. Okay. DC gain. Okay. You have to put S equal to 0. Okay. Then answer should be 2 by 5 is 0.4. Okay. Now, for this question, one point I just want to add it here. That suppose a question is given to you. This is the plant is given to you. Okay, G of S. I am just adding a unity feedback system. Okay, just negative feedback. This is 1. I am just here. I am just giving to a summation block. This error here the input is given. Okay, let me give in as V in and output is V naught. Some part of the V naught is common in feedback. Having a unity gain means this V naught is coming here, and here V in minus V naught, this is positive, this is negative, and whatever the error is coming, that is E. Okay, it is going to some controller. Okay, PID whatever will go in the next step. Then this error, this this controller block, let's assume that now the controller is a black box. It may be a KPKI or KPID or PI controller, whatever. After this controller is trying to make this error to 0. Okay, it means the V in equal to V naught and you are giving a perfect output V naught. So generally this is a closed loop control system. Okay, now assume that forget about the controller part. Now here G of S is given to you in the same equation, S plus 2 divided by S cube plus 3S square plus 7S plus 5. Now I am asking you that whether this system is stable or not. Whether the system is stable or not. Okay, we will detailedly discussed when we will go to analyze the root locus whenever we board a plot. So at that time also we will discuss it, but for now I just want to give a small shortcut to you. Okay, to solve this question by looking at this equation, whether you can able to tell that whether the system is stable or not. Remember that whenever I am asking you that to find out the system stability, remember that you have to always find out the stability of the closed loop system. So remember that this is the open loop system is given G of S. The closed loop system is nothing but V naught by V in. Okay, this is a closed loop form. Now this is what, if it is unity feedback system is there, then what you do whenever you see a unity feedback system, always first write the G of equation. What is the G of equation is given? S plus 2 divided by SQ plus 3S square plus 7S plus 5. Just copy paste the GS equation, but you have to find out the closed loop transfer function. Closed loop transfer function for a unity feedback system is nothing but whatever the numerator is there to you, S plus 2. Okay, you simply what you do, you add it in the denominator. Okay, S plus 2 I am adding. Okay, once you add it, now whatever the denominator term, you just rearrange it. Okay, now this will become S cube plus 3S square. Okay, 7S plus S is 8S and 5 plus 2 is 7. This is the denominator part. Now this is the closed loop transfer function. Okay, this is the closed loop transfer function. Okay, so now what you do some inner product. Inner product means I am just This shortcut is only valid for third order system, and remember that in the examination they will never give you fourth order and fifth order equation. Either they will give you second order equation or third order equations. So this shortcut will be most of the time 90% of the question will be solved by using this shortcut. So find out the inner product. Inner product means these two product coefficient 8 into 3 is 24. Okay, outer product is means whatever the outer product is, the coefficient of this 7 means 7 into what is the coefficient of SQ is 1. So outer product is 7 into 1 is 7. So remember, as long as your inner product is greater than your outer product, the system is always stable. Don't do any RH criterion, don't do any Bode plot, don't do any root locus. By looking at the question, you can directly say that the system is stable. If your inner product is always greater than outer product, the system is stable. If the inner product equal to the outer product, the system is marginally stable. And if the inner product is less than the outer product, the system is unstable. If a system is unstable, then you have to add a compensator or a controller to make the system stable. So that part we will do in the upcoming sessions. Okay, most frequently when the root locus or the RH criterion will come. But this just I'm explaining here because I just failed to tell you that. Okay, so you understand this. Okay, how to find out the DC gain of the system, how to find out the closed loop transfer function by open loop transfer function. If a unity feedback system is given directly, don't do anything, just whatever the denominator, just write down in the numerator is write down the denominator, and then by looking at the denominator you just go to the inner product and outer product and whether you find out the system stability or not. If you clear this question number 8, let's move to the question number 9. If you have any doubt, then tell me.
Sir, what is mean by DC gain, sir?
DC gain means actually whenever your frequency equal to 0, DC means what here? DC means your frequency component equal to 0. Okay. So whenever a signal is given to you, let me give to a signal, let's say triangular signal is given or a triangular periodic carrier signal is given to you. So if I am asking you to find out the Fourier series of the signal, then the Fourier series of the signal is composed of lots of harmonic components plus the DC component. So DC component means at frequency equal to 0, frequency means your omega equal to 0. So S equal to j omega, when omega equal to 0, S equal to 0. So at 0 frequency, whatever the value is exists, that is called a DC gain of the system. Clear?
Yes, sir. Thank you, sir.
So in that way, you have to find out the DC gain of the system, but it depends on the question. You look at the question, whether they are asking the DC gain for the open loop system or the closed loop system. But mostly here in this question, the closed loop system part is not mentioned. He has nothing tell about the unity feedback system, closed loop system, because that are not discussed yet in your theory part. So that's why I'm just taking a simple example G of S, how to find out the DC gain of any system. Just put S equal to 0 and find out the DC gain, because DC gain is nothing but whenever you go to the steady state error, you know Kp Ki, and because if you don't know, you will make going to learn it. So that are called the DC gain of the system. When the frequency equal to 0, what are the values are there? Okay, so this part will be later most frequently will be used throughout the whole control system whenever you're dealing with the steady state error. Okay. So if it is clear, then I am moving to the next question. Okay, let's move to the next question. Okay, this is the relevant question of question 8 and question 9. For this system, you find out the DC gain is okay. Then, is there a stable pole located on the right hand side of the plane or not? First, can you tell me by looking at this whether the answer is true or false? He is asking that a stable pole located on the right half of S plane. Is there any stable pole located on the right half of the S plane?
No, sir, because this is you have proved that this is a stable signal,
Yeah,
so we can say
it is.
that this is
Yes.
false.
As it is a stable system, no poles will be existed on the right hand side. Okay. By looking at the question, don't solve it. Okay. Don't find out the roots to locate whether it is located on the left hand side and the right hand side. Just I am saying that use this formula for third order system. Okay, then there is no poles on the right hand side, so the system is stable. So here for this question, as the no poles are on the right hand side, the answer is false. Okay. Now let's move to the next question. Okay, no other questions are there. If there is no other questions are there, let me go back to one final thing I just want to tell you. Okay, we have not taught nothing about transfer function. Transfer function, you already know that if the input is there. Let me give a brief introduction of a transfer function. Transfer function is mean nothing but you find out the Laplace transformation of the output, okay, divided by Laplace transformation of the input, okay, when all the initial condition you have to make it 0, because in that question which I have solved here, in this question we are assuming that all the initial conditions are 0, because we don't know that what is the initial charge of the capacitor at t equal to 0 minus, and what is the current at 0 minus. So all these things you are assuming that 0, we have solved these questions. Okay, so that is the assumption you have to make in all the question. Whenever initial value is given to you, make it 0 and find out the Laplace transformation. Then after finding out the Laplace transformation, the output divided by input, then that will give you the transfer function. Okay, so that part, okay, we actually the transfer function and block diagram, it's mostly discussed in the next week. So how the block diagrams reduction you have to do, how signal flow graph you have to do, so all these things we will discuss in the next class. So before coming, you just go through once the lecture, okay, and then only you can get, but I have lots of shortcuts there how to do the reduction, okay, of the block diagram. I will tell you in some questions, but before that let me give some convolution property, okay, because the convolution is very important. Let me go to one or two questions, then I will wind up here. Okay, so suppose u of t multiplied with u of t. Okay, so if you find out what is the convolution of the system, so you know that convolution in time domain is the multiplication of the frequency domain. Find out the Laplace transformation. This is 1 by s, this is 1 by s, multiplication is 1 by s square. Take the inverse Laplace transformation. ILT is inverse Laplace transformation. What is 1 by s square? Inverse Laplace transformation is t u of t. T u of t is, I told you, this is nothing but ramp signal r of t. So the answer for this signal is r of t. So remember all these values. U of t, convolution of u of t is nothing but a r of t. You have to remember all this value. Okay, next, this is the question number 1. Question number 2, if I am giving to another question, uh, this is a powerful question actually. Okay, let me do it for you. This is the last question. I will solve it for today. Okay, this is signal is given to you, let's say x of t, which is spreading from -2 to +2, having amplitude of 1. I am asking you to find out y of t, which is nothing but x of t convolution with x of t. If you can solve this question, I am really, you are a hero. Okay, you are understand the first part. Okay, so what to do? X of t convolution with x of t. So first of all, I told you how to write the equation of this line. What is the equation of this line? U of t plus 2, it is starting at +2 value, okay, because if you put t plus 2 equal to 0, then the time value is -2. That's why I'm writing u of t plus 2, because this is the advance in time. That's why u of t plus 2 minus u of t minus 2. This is the equation of this x of t. I think everyone is clear how I write this equation. It is clear to you?
Yes, sir.
Okay, so here asking that convolution of x of t with x of t. So another time you have to write x of t, same signal, u of t plus 2 minus u of t minus 2. Now you have to convolute it. Okay, convolute, first you do multiplied. Okay, so what to do? U of t plus 2, this first part u of t plus 2, whenever it is multiplied with u of t plus 2, then what you will get? U of t convoluted with U of t in the first question I told you it is R of t. Okay, so here remember that convolution of this is the convolution, I'm not multiplying here. This signal x of t is convoluted with x of t. Remember that x of t minus t0, whenever it is convoluted with another signal y of t minus t1, then you will get another signal z, which is nothing but t minus, in place of t0, what you in place of t0 you have to put t minus t1 minus t0. Okay, so whatever this t, just replace this t minus t naught like that. Okay, so what you do here, whenever u of t convoluted with u of t, you know that the answer will be r of t. So write down r of, but what you have to write inside? So this t plus 2, you have to put in this t. So it will be t plus 4. Okay. Again, this just you have convoluted with this. Now you have to convolute with this. Okay. So what u of t minus 2 this. So this will be minus sign. This is r of t. This t minus 2 you have to put in this here. So t minus 2 and plus 2. So it is r of t. Then this is the first. This I'm writing 2. Now this is 3 and this is 4. So now first and 3, the if you convoluted with first and 3 you will get this value. If you convoluted first and 4 you will get this value. This is first and third, this is first and fourth. Now you do 2 and 3. 2 and 3 mean negative sign. U of t convoluted with u of t is r of t. R of, in place of t you have to replace this t minus 2. So t minus 2 plus 2 is again t minus. Now you have to convolute this part is 2 and 3. Now if you convolute in 2 and 4 you will get plus sign r of t minus 4. This is 2 and 4, convolution of 2 and 4. Okay, this is from the convolution. Okay, but you already know that if this signal is converted to the same signal, if the same signal is converted to the same signal, you will get a ramp signal. Okay, so now can you write the equation of this in the graphical form? This is equation 1. Can you plot it in the graphical form? What is the plot of this equation in the graphical form? I am just plotting here because to understand it better. I am just writing the equation r of t plus 4. This r of t is get 2 times of r of t plus r of t minus 4. Now let me start draw a x-axis. R of t plus 4 is somewhere here at t equal to minus 4. Now you are a ramp signal, you are going up to infinity, right? You are going up to infinity with some slope. Now you have to come back at r equal to t equal to 0. This at t equal to 0. You have to come back 2 times. Let's it come back 2 times. If you come first time, if you come for the first time, you will be in the horizontal axis. If you come second time, you will become like here. So now you are coming here. Okay, and now at t equal to 4, you are going back, but this is plus slope is pushing you off. It's pushing off. Now this is just a triangle you will get. Okay, this triangle it get. This is 4 and this is 4. What is the slope of this line? This is slope of the line is 1. So accordingly, you have to find out this height 4. Okay, so clear, this is just a triangular signal you will get if a rectangular signal is convoluted with same duration. You see, this is the same duration signal minus 2 and 2. If it is convoluted to the same signal, you will get a triangular. But I am giving a homework to you. If minus 2 and minus 2 convoluted with another signal which of unequal height, let's say it is from minus 3 to and 3. If you do the convolution, then you will not got a triangular, you will get a trapezoidal waveform. Okay, so do it by yourself and plot that curve and find out the slope of the line. So if an unequal width you have convoluted, you will get a trapezoidal waveform. Okay, so we are stopping here for today. The next time we will discuss more about the block diagram reduction and the signal flow graph for the next week. Okay, So thank you all of you for attending the session.
Sir,
Sir, whether this recorded video is available?
Yeah, actually this recorded video I'll upload by tomorrow or day after tomorrow in the weekly log sheet. Okay, I think you can have access to weekly log sheet. Okay,
Okay.
so you can go to that link and watch in the YouTube. Okay. Okay, thank you so much to all of you.
Thank you very much.
Sir, one last doubt, sir.
Right, right. Yeah,
You have
tell.
tell us that inner product into is less than outer product. You have told no, sir.
Right,
In it, in the denominator, you have added the numerator part, no, sir.
right.
Is it simply like
Yeah, you
if
can
the
directly,
feedback is given like that,
yeah, you can directly add the
you can directly
whatever the
record.
numerator it does. Simply add it the denominator if it is a unity feedback system to make a open loop system to closed loop system. If open loop system is given to you and is saying strictly in the question that it is a unity feedback system, then write the open loop transfer function and see whatever in the numerator. Simply add in the denominator. That's a give you the closed loop transfer function. You can try by yourself.
Oh,
Suppose g of s, h of s equal take 1, then g of s divided by 1 plus g of s is the closed loop transfer function. You find out, you will get the same answer.
yes, sir. Thank you, sir.
We'll do it in the next class. Okay, we'll do lots of questions based on that. Don't worry.
sir,
Yeah.
hello, sir.
Yes.
Sir, I need a PPT of previous class, in the previous semester,
Actually,
like you have said.
in the weekly log sheet, I have uploaded to the PPT folder also. You can go and download there. Okay.
From where, sir?
There is a weekly log sheet you can available on the course link. Na? You go to the course link, go to Swam Patel and go to your control engineering. You'll find out the link there. Okay.
Okay, thank you, sir.
Otherwise,
Week one,
yeah.
sir. Week one recording of only another sir class there, sir.
No, no. And actually, in the first lecture, I have uploaded in lately because they have not given me the access to upload. But now it is available. You can check. Both the lectures are there on the same Google Sheet.
Okay, sir. Thank you, sir.
Okay. Thank you. Thank you, Olaf. I'm just stopping the session here.